find the minimum value of this quotient. It's an SMO, similar to an SMO problem, junior problem, and we want to do it without calculus. Now, calculus may not be too much trouble here. You do the quotient rule, and you need to find your horizontal tangent lines by setting the derivative equal to 0. But there's a way to do this without calculus. Okay, so that's the approach we'll adopt tonight. Okay, so we want to solve this without calculus. All right. Now, meaning find a minimum value. Now, notice this is the quotient of two positive numbers. Both discriminants are negative. So that means both of these parabolas are always above the x-axis. So it's the quotient of two positive numbers. Now, I don't know how important it is to even note that really. But in any event, you'll notice that the denominator, 9 times these two terms are these two terms. Okay, again, 9 times 6 is 54, 9 times 2 is 18. And so one would anticipate the 9 being the quotient, okay? And indeed it is. And notice that this part right here would be 7 minus, this long division is really easy almost just to do in your head. 7 minus 9 times 13, right? Okay, 9 times 13 is what? 117, and 7 minus 117 is the 110 you see right here. You got a minus sign here, okay? Now, the big observation here that makes this thing kind of melt in your mouth is if you minimize the divisor here, if you minimize this, you're going to maximize the whole quotient, okay? And I've written it down right here so you don't have to keep listening to me. But if you minimize this bottom part, the divisor, okay, that's the same as maximizing the entire quotient. But if you maximize this part right here, you're going to minimize the whole thing, right? Okay, so maximizing just this part right here and then subtracting it from 9 will make this a minimal value, which is what we're looking for, right? What we're looking for, a minimum, okay? So that's the path. Now, yeah, a lot of you might remember the vertex formula. I just went ahead and completed the square right here. This is a complete the square step. Complete the square. I'll write it CTS. Okay, CTS, complete the square. And when you complete the square, it's very clear that this thing achieves a minimum value at x equals minus 1/6. Okay, if x is equal to minus 1/6, this entire part vanishes, and this would be equal to 77 over 6. You'll see that, it's kind of cool. Again, you could use the vertex formula, but I don't like memorizing stuff like that. But so again, if x is equal to minus 1/6, this part goes poof, and you have 6 times 77 over 36, but that a pair of the 6's cancel, and so you get 77 over 6. Okay, and again, that would be the minimum value for this, which is going to make, see, if this is minimum, this is maximum, and you're subtracting the maximum from 9 to make this entire thing a min, right? So it's a slightly convoluted, but it's not too difficult to just to say it. So what we have right here is 9 minus 110, which was the remainder upon the long division a while ago. Okay, over 77 over 6. Okay, now let's get some more space here. So, folks, this would be the same thing as equal to, 9 minus, let's invert here. 9 minus, if you invert and multiply, you would get minus 610 over 77, right? And then, so your common denominator is going to be 77 by default, sort of. And so this would be what, that is 660, folks, right there. Let me make a correction there. That would be 660, right? 660, sorry about that. Let me erase that to be professional here. Erase, and that would be 660, right? When you invert and multiply, 6 times 110 is 660. Now notice here that this would be 9 times 77 would be 693. So you get 693 minus 660 all over 77. Again, that's common denominator, converting a pair of fractions into a single fraction. Minus 660 over 77. Okay, ladies and gentlemen, and that is equal to 33 over 77. We're almost done. Can you hear the drums rolling? 33 over 77. And then 33 and 77 have a common factor of 11. So that minimum value is going to be 3 over 7. And it happens at minus 1/6. We didn't ask for that. This is the answer, folks. 3 over 7 is as small as that quotient of quadratics can get. So that completes the process. And again, the two key steps were doing the long division, seeing that that's useful, and then making this divisor as small as it can be to maximize this quotient right here. But if you maximize this quotient, that's going to minimize the original problem. That's the idea. And along the way, one could have actually used the vertex formula for parabolas, or you just do the complete the square process, which was this stage right here. Okay, so that does it. Let's see, 3 over 7. So the answer to the question is, where are we at here? Find the minimum value of the quotient. The minimum value of this quotient is 3 over 7. I like the problem, folks. We didn't have to do the quotient rule of calculus and a bunch of tough algebra, just a couple of simple observations. And we completed that problem without the aid of calculus. Thanks for viewing.